Welcome to Math 1324. This is section 3.4. All right, in question 1 here, we want to find I, the rate per period, and N, the total number of periods. So let's see. We're making monthly payments. All right, so monthly would be 12. We're doing this for 9 years. All right, so let's see the total number of payments. 9 years, 12 months, or 12 payments per 1 year. 9 times 12, we get 108 payment periods. I is the rate per period. Well, let's see. Interest rate 9.55%. So 0.0955 divided by our payments per year, which is 12. All right, here it is with lots of decimals, but they say round to 4 decimal places. So 0.0080. All right, so let's see. Here we want to solve the following problem. What are they giving us? They're giving us N is 30, I, our rate per period, 0.025. Our payment is 214, and present value, PV. So here's this formula. Now I'm solving for PV, which means I just have to plug in all these numbers. So payment 214. N is 30, I 0.025. All right, so here's all the numbers. Now, I don't want to write too much down because if I write it down, the rounding is going to be a problem. So the question is, well, where do I start here? Start right here. Put in 1.025. All right. We need to raise it to this exponent. All right, so on your calculator, you should be looking for a key that looks like y to the x, because we need the exponent, and you need to look for a symbol that looks like plus/minus, because we're going to need to enter the 30 and then change the sign. Now, your calculator might also have the exponent key that looks like this, and the button for changing the sign can sometimes look like that. So your calculator is going to have one of those. So we need 1.025, raise it to the 30th power, and we need the sign changed. All right, so it's going to be a little different whether it's this set of keys or this set. Once you get that, then you're going to need to change the sign of that answer, add it to 1, divide by 0.025, and then multiply by 214. So we get this big long number. We're going to round it to 2 decimal places. All right, the thing after the 8 is a 2, so drop all that stuff off. And so we get 4,479.08. All right, so let's see. Here we are given the present value. We're given I. We're given the payment. I need to get my hands on N. Well, N is all tied up here as an exponent. So we're going to have to unravel all this stuff. So first off, divide by the payment. All right, did that. Next, I'm going to multiply both sides by I to get this to cancel. See, that's why that's there. Next, N is here with a negative sign. So I'm going to move all this junk to the left, making it positive. On the right, I'm going to have 1 minus all that stuff. So that's where we're at. At this point, it's about as cleaned up as I'm going to get it. I use the natural log to get the exponent to come in the front. Remember our properties of logs. The log of something raised to a power, this thing comes out into the front. And that's where you see it right there. And we get the ln of all this junk on the right. All right. And so divide by this natural log, and we get our formula for n, the total number of payment periods. The derivation of how they did this is also shown in the textbook on page 164. Plugging in all the numbers, all right, plug in the present value, our payment, our I. All right, so we get this multiplied by -1. And then rounding, they say round up to the nearest whole number. So 57 point anything would round up to be 58. All right, explain what is meant by present value. I can let you read that part. And how is it like taking an auto loan from the bank? All right, question 6. We have an 18-year annuity. It's compounded how often? Annually. Okay, so that means n is 1. All right, we want to receive payments of $1,200 over an 18-year period. So let's see, we want this payment. I is R over N. N is 1. How many payments total? Well, 18 years, but we do this one time per year. So 18 times. And so now it's just a question of plugging in all the information, the I, the N, and again, making sure you don't have too much rounding error by writing too much down. And so we're rounding this to 2 decimal places. So this is a 2.9. So round this up and we get a 3. And that concludes section 3.4.